in the first one, there's nothing to do. You just get A. In the second one, it's 2 times 0 minus 23. So A ends up equaling minus 23, like that.
Okay. Okay.
That's a common test question to get.
Okay. Okay.
Any questions on that?
No.
Derivative, then try the endpoint. If the endpoint was 1 or in between point, then you put 1 in. Sometimes there's variables on both sides. You got to solve from previous courses. Okay, next problem here. They give you a function. It's called a position function. So they're telling you that S of t equals 4t minus 0.8 t squared. The first thing it asks you for in part A and B, we'll do the first part of part A, is to find the velocity.
Okay.
So the velocity is the derivative of position.
Okay.
Okay, so can you take the derivative of this for us, please?
Yes. I got 4 minus 1.6 t.
So that's what goes in that first box.
Okay. Oh, okay.
The next part of A is to find the acceleration. The acceleration is the derivative of velocity. So which means you have to take a derivative of what's here.
Okay. It would just be 1.6.
The negative goes with it.
Oh yeah, negative 1.6.
Very important. Yeah. So that's what goes in this box here.
Okay.
Questions on that?
No.
Okay, so part B is how long does it take the rock to reach its highest point? So if you were to graph the original function, it would go up and come down. How long is the x value? Now you can do this without calculus. Like you could just graph it and find that point. If you want to use calculus, you go back to the derivative. So you set the derivative, which is velocity, 4 minus 1.6, you set that equal to 0.
Okay.
And then you solve for t. Okay, so could you do that for us, please?
Yeah. I got negative 2.5.
But think about what you just said. It's time, negative 2.5 seconds. Does that even make sense to you? Have you ever told someone I'll be there negative 2.5 seconds or hours?
Wow.
No. So you've got a sign error, and that's it. Like, I'm not trying to be critical of you. I'm just trying to point out, like this is why students, why you might have had trouble in the past. Like it's a small thing. If you subtract 4 from both sides, it's minus 1.6 t equals negative 4. If you forget about that, um,
I didn't write the negative sign in the
yeah,
floor. Yeah.
yes, it's a small thing. I mean, I was at Walmart the other day and 2 people in a row left bags at the self-checkout. I mean, it happens. I've done it. I mean,
Yeah.
it's whatever. But so in 2.5 seconds, it reaches its maximum height. Okay.
Okay.
The next question asks, well, how high does it go? And what's challenging about this problem is you have to know whether you're going back to the original or the derivative or the second derivative. So how high does it go? We want to know the y value now. So you go back to s of t. You want to find s of 2.5. You want to put, 2.5 in for t in that original equation. Go ahead and calculate that for us, please.
I got 5.
I agree. So that's the answer there. And again, not all questions are created equal. So like, if you get this on a test, you may say, well, I don't know if I want to spend all my time on this, because you can see compared to the previous problem, this is taking up quite a bit of
Yeah,
effort, all the parts to it. So now it says, how long does it take the rocket to reach half the maximum height? Okay, so again, I like drawing the picture each time. So that's 5. We're interested in how long does it take to reach 2.5. And notice there's 2 places where that occurs. Once on the way up, once on the way down.
okay.
So we're setting the original function equal to 2.5. So 2.5 equals 4t minus 0.8 t squared, like that. This is a very challenging problem because you've got decimals, you got a quadratic. Like your choices to solve would be factoring, probably doesn't factor. Completing the square, you don't want to do that. Quadratic formula is what most students go to. I would tell you to graph. Do you have a graphing calculator that you're allowed to use in this, or can I use Desmos? What would be best for you to?
I mean, we use graphing calculators, but if you want to use Desmos, that's fine. I know how to,
Okay.
yeah.
Okay. So what I'm going to do here is graph the original and then this other one, and I'll snip in a picture of it so you can see what I'm talking about. And actually get this little tighter window. And as I sort of suggested, the answers are not, plus it even says in there, like, I think it says to round to a certain number of decimal places. So you can see there that it's, let's see, 2 decimal places. So the answer is 0.73 for the first one and 4.27 for the second one. 0.73 comma 4.27. Once on the way up, once on the way down. And you'll notice when I graph it, I use X instead of P. Same thing for your graphing calculator there.
Okay.
All right. How long is the rocket keep saying rocket. I guess it's a rock. Aloft. So this time they're asking for where does it come back and crash down there. So there's 2 ways to do that. You can set the original function equal to 0. Or you can go back to Desmos and graph and find the intersection with the 0. What would you like me to do? Factor this by hand or go back to the graph?
I'd probably go back to the graph for me.
Okay. And that's, if you haven't done that in a while, it's it's the second calc, I think, intercept, maybe. Anyway, it ends up being t equals 5.
Okay.
Which is a long time for a rock to be in the air, truthfully. I mean, you'd have to really throw it up pretty high.
Yeah.
I think you'd be surprised. It'd actually be a pretty fun experiment to do that with students. Is you think it's in the air a long time, it's probably only in the air for like 2 seconds, 3 seconds.
Yeah.
All right. Take a deep breath here. And we're on to 22. All right, when a bactericide is added to a nutrient broth, okay, we don't care about that. here's the equation, right? And they want the growth rates. So rate means derivative at 0, 5, and 10. So you have to take a derivative of this. Now, it looks kind of awkward. 10 to the fourth is a number, 10 to the cubed is a number, and 10 squared is a number. So try
Mhm.
not to overthink it here. Actually, let me just rewrite it here. Try not to overthink it because it's the derivative of a constant is 0. It's power rule, even though maybe it looks like something else.
Mhm.
Could you take the derivative of this for us, please?
Yeah. I think I did it right. I
Okay.
got 10 to the fourth plus 10 minus 10 squared times t, or 2t.
Okay, so the derivative of the first one is 0. 10 to the derivative of 10 to the fourth is 0. What if this were just t? What would the derivative be?
Um, it would be 1.
Yes. And what if it was 2t? What would the derivative be?
It would just be 2.
And what if it was 10t? What would the derivative be?
10.
And what if it was 10 cubed t, like it is there? What's the derivative?
I think it would still be 10 cubed.
Yes.
Yeah.
Yes. Okay. So the derivative is the number in front of that. The constant always comes with it with power.
Okay.
So for the second one, the derivative, like you bring the constant down. What's the derivative of t squared?
2t.
2t. Okay, now if you don't like the way this is written, because I don't like the way it's written at all,
Yeah.
10 cubed is 1,000. 10
Mhm.
squared is 100 times 2 is 200.
Okay.
And it's okay to do that. It's okay to actually do that from the beginning. If you really don't like it, make this 10 to the fourth, 10,000, 1,000, 100 t squared. That might be a good strategy. That way you're not, taking a
Yeah.
chance here of doing it wrong. So, not intentional or anything, but so now the questions questions are pretty straightforward. You're putting these values into the derivative.
Mhm.
You're putting 0 in for t, 5 in for t, and 10 in for t.
Okay.
So go ahead and do that, and let me know if you have any questions. Um,
For 0, I got 1,000.
okay.
For 5, I got 0.
Okay.
And then for 10, I got negative 1,000.
So one of the things you should know about the way these problems are written is that there are patterns like this in the answers. If you ever get one, it doesn't have to even be the same numbers, but you might see the same sort of like number 0 and then negative the number. And that's where I tell students sometimes you can sort of pattern your way um, through it if you aren't sure. But
Yeah.
Okay, next question, almost through this one, 20. All right, so the next question I have here is like 5. Feels like we would have already done this, so let me snip this in and you tell me if you still want us to do it.
Okay.
I'm happy to do it, just asking.
Oh, you already taught me how to do this. Yeah, I'll do this on my own. Yeah, you can go to
Okay.
the next.
Up to you. All right, so next one I'm seeing here is implicit derivative. This looks new to me.
Yeah.
All right, so implicit derivatives, when you have an x, you treat it the same as before. So what is the derivative of x cubed?
3x squared.
3x squared, good. And then you treat y just like x, so its derivative is 3y squared. But there's a big but here. The but is that it's you have to put a dy dx whenever you take a derivative with respect to y.
Okay.
Does that make sense?
Yes. Yeah.
Now on the right, it's a little bit more complicated because it's product rule.
Okay.
So the let me just write it out. So like you let's split it here where it's 18 f. Actually, let me do this off to the side. So f is 18x, g is y. So the derivative of f is 18. The derivative of g is dy dx.
Okay.
So the derivative is 18x dy dx. That's the fg prime plus 18y like that.
Okay.
All right, so now there's a lot here. I don't remember if we've done any stirs, but I'm just gonna grab this and hopefully, yeah. So once you've taken the derivative, it's really just an algebra exercise. You're solving for dy dx, which means you have to get dy dx on the same side and everything else not on the same side. So you're gonna subtract the 3x squared from both sides, and then you're gonna subtract this 18x dy dx
Okay.
like this. So it ends up looking like this, where let me get this going. So it's 3y squared dy dx minus 18x dy dx equals 18y minus 3x squared. Just take a moment to look at that, look that over, recognize that all I did was kind of rearrange terms. There's no calculus at this point, like calculus is done.
Okay.
All right, so now you factor out a dy dx. And you get 3y squared minus 18. 18x equals 18y minus 3x squared, like that. So once you factored it out, you divide both sides by it. So you're going to divide both sides by this 3y squared minus 18x, 3y squared minus 18x. Now, what I can't remember is if Pearson will take what you have here, or if you need to, like you can factor out a 3 from both. So let me do that here. So it's 6y minus x squared over 3y squared minus 6x. And you can see that those threes cancel. So dy dx equals 6y minus x squared over y squared minus 6x. So I would probably do the reduced form. But if you don't remember to do it on the test, maybe you'll still take it. I don't know. It's kind of like,
On multiple choice from what I remember.
oh, that's good.
Yeah, so
Makes it easier to grade as well.
it,
There's also
it
a few
gives
things
you
you can do to
the answer,
make
right?
that
It gives
easier.
you the test score right away, I'm pretty sure. So
Again, you take a derivative and then it's just algebra. You're just moving stuff around. You're not actually doing any more calculus after that point. So the next problem here is related, thank goodness. We probably should have done this one first, but we didn't know it was the next one. Right. Question. Okay, sorry. We're gonna do this. So we got to take the derivative of this, and like I mentioned, when you take a derivative with respect to y, you treat it like x. Okay, so what would the derivative be if it was 9x to the fourth?
it would be 36 y to the third.
Y to the third, and then you write this dy dx. So whenever you take a derivative with respect to y,
I'm gonna have to remember that. Hold on. Okay.
so then with x, you just it's the normal x. So that's 63 x to the eighth equals
Would it just be 5?
5. But again, whenever you have a derivative with respect to y, you always have to add on a dy dx.
Okay,
Plus, what's the derivative of 11x?
11.
11, yeah. So this is just like the last problem where you have to solve it for dy dx. So I would recommend moving the 5 dy dx left, the 63x to the eighth right. I'd like you to try solving this for dy dx.
Okay. Can I factor out a dy dx?
Yes, do everything just like in the last problem, basically. This is the important part, is to be able to solve for dy dx.
Okay. I got 11 minus 63x to the 8th over 36y. Yeah,
The third.
36y to the 3rd minus 5.
That is correct. Okay. Now, this problem is different than the last one because now you have you have to solve I'm not solve, you have to put 1 in for x and y. So the
Okay.
nice thing is that whenever you put in for 1, you just get the number. That the coefficient. So you can put in 1 to the 8th is 1 and 1 cubed is 1. Basically 1 to any power is always 1.
Yeah.
Right, so can you simplify that for us, please?
Yeah. I got negative 52 over 31.
Yeah, and sometimes the answers don't mean anything.
Okay.
So we're gonna do the next. There's 2 of these inverse derivative problems. These are the absolute worst to explain. You never do them except in this course. We're gonna do 9, and then we'll go back to the previous one. So they're the formula for the derivative of the inverse df dx inverse like this, and it's 1 over the derivative at the point. It's kind of a weird formula. In this problem, they say that the function has an inverse. The graph passes through the point 2, 3. So see how this 3 matches with this 3. So remember what the inverse x's and y's, they switch
Mm-hmm.
from the inverses. But essentially, you need the inverse. You need the derivative at that point, and they tell you the derivative at that point is 1/4. So this one becomes 1 over 1/4, which is 4.
Okay.
Is that okay?
That's all that the answer is?
Yeah. Yep.
Oh. Okay. I thought there was more.
Well, then the other ones, the next one there is a bit more. It's
Yeah. Okay.
all right. So in the next problem here, which is number 8, which should have come before that one, or it should have come after the other one. The first thing is that they always give you a function. Okay, they give you some sort of function, and you have to, if they don't give it to you, they tell you that when you put 3 in for x, this is now x, 4 times 3 cubed minus 7 times 3 squared minus 4. Could you calculate that for us, please? This is putting 3 in and for x and tell me what you come up with.
Yeah. Uh, 41.
41. We shouldn't be surprised because that number is right there. Okay. So
Okay.
keep in mind, this is the ordered pair 3, 41, which means you switch them 41, 3.
Okay.
That's the whole inverse thing. All right.
Mhm.
So that's thing 1. Like normally they don't give you the point in the problem they do, but it's important to that. The second thing you need to take is the derivative. Could you take the derivative of that original function for us, please?
Mhm. I got 12x squared minus 14x.
Good. Okay. Now the formula is for this F inverse, it's 1 over the derivative at a point. Well, guess what that point is? It's the 3.
Mm-hmm.
So you got to find 12 times 3 squared minus 14 times 3, like that.
Okay. I got 1 over 66.
There you go. There's your answer. Any questions on that?
No.
Okay. The other thing to remember for something like this is that, like, you may not remember, was it 41 or 3? It's going to be the one that's more workable in some ways. Like 41 would give you a huge number. That wouldn't make any sense. Like it's usually like a smaller fraction, if that.
Yeah.
All is okay with, and these are just kind of like, I hate saying it, tricks to do well in this. Like you gotta think about that. Okay. You need prioritize questions here. I mean, I see we're just kind of going in order the rest of the way. I think it looks like all the rest are in order. Like, is what we're doing okay, or do we need
Yeah,
to
that's perfectly fine.
Okay. always ask? Because yeah, you get. I don't know if you ever had to, you probably haven't had to talk to a lawyer, but they bill you by like the 15-minute increments. So like you make sure that they are helping you with what you need, or it gets expensive
Yeah.
pretty quickly.
Mm-hmm.
So I know I'm cheaper than a lawyer, but it's the same principle. Like, let's not waste each other's time here. All right, so the derivative here, like at some point you learn the derivative of natural log, sorry, y prime of natural log is 1 over x. And that is true, but it doesn't account for the chain rule. So
Okay.
really it's y equals natural log of u, and the derivative is 1 over u times u prime. What is u prime? Well, it's the derivative of the inside function. So in your problem, it's really y equals natural log of u, but u is t to the power of 3.
Okay.
So the derivative is 1 over u times u prime. What is u prime in this example? What is the derivative of t to the power of 3?
3t squared.
3t squared. Good. So now you plug those back in. You say, okay, y prime is 1 over e cubed times 3t squared, which is 3t squared over e cubed. And then you can simplify. You can simplify here. T squared over t cubed is 3 over t. And that's your final answer on that one.
Okay.
Hopefully you've seen that before.
Yeah.
Okay. All right. New question here. It says use logarithmic differentiation for this. I don't want us to do that. I think that's a mistake here. You're not checking your work, so we don't need to do it that way. Is it okay if I don't do it that way?
Yeah.
All right. So what I would do is I would FOIL. I'd say, okay, what is t plus 6 times t plus 5? FOIL. That's t squared plus 5t plus 6t plus 30. Combine like terms. You can combine those there. T squared plus 11t plus 30. And then multiply everything by that t. So it's t cubed plus 11t squared plus 30t, like that. All right, so we still haven't taken any derivatives, no calculus, we're just rewriting. This is really just all rewrite here.
Mhm.
But the derivative is much easier now because you can take the derivative using the power rule. And that's all it's asking for. The answer is just asking for to find the derivative.
Okay.
So while you could use this logarithmic differentiation, it is super useful in some contexts, just not this one. So why don't you try taking the derivative here, and I'll confirm your answer here.
I got 3t squared plus 11.
T 11t plus
Oh, there was a square root. That's my fault.
square. Yeah. Square root is this one.
Yeah. 11t.
I don't know anything about the music world, but I know that when I'm around people in the music world, if I call something wrong, like a guitar, or it's the wrong kind of guitar or drum, they get sort of angry. It's kind of the same thing here, like big difference. What about that last one? What's the derivative of 30t?
30.
30, good. Okay, there you go. So there's your answer for dy dt. Keep in mind notationally dy dt and y prime, they all mean the same thing.
Yeah.
Okay, on to number 12 here. This is another just straight rule. Okay, it's like a pure rule. The example, the reference would be like a to the x. I think it actually is b to the x. Let me do it that way in most of the reference sheets. And the derivative is itself times the natural log of b. So in your problem, what is the value of b in your problem?
2.
2. So try telling me what the answer is, or give me the answer based on what I just said.
So would it be 2 to the x times ln of 2?
Yes.
Okay.
Like we talked about earlier, some of the questions are not that difficult, and some of them really are a lot of work and effort.
Yeah.
All right, let me know when I can move on to 13.
Yeah. You can move on.
All right. Okay, so 13, we actually do have to use this logarithmic differentiation, which I was hoping to avoid, because it's never clear. Logarithmic differentiation is essentially a rewrite step,
Okay.
and you take the natural log of both sides of the equation. So if you see the original is y equals 6 to the z to the 9th power. You start by taking a natural log of both sides. Okay, that's kind of step one. ln of both sides. Okay. Then you bring the exponent down in front. Always bring the exponent down, which in this case is a function. So it's like the z to the 9th times the natural log of 6. Is that okay? Do you remember that from maybe a previous course?
Yeah.
Okay. Now, the other thing you can do here is just because it's the natural log of 6 is a number, usually the numbers go in front. So I probably would rewrite it like that. So it's natural log of 6 times z to the 9th, but somehow keeping in mind that natural log of 6 is a number. It's not a friendly number, but it's a number. It's like that 10 to the 4th. It's just a constant. Okay. Okay. Now we're basically doing implicit differentiation. Okay, so when you take a derivative of the left-hand side, the derivative of natural log of y is 1 over y. But we mentioned when you take a derivative with respect to y, it becomes dy dx, like that.
Okay.
Do you remember that from a little earlier? We were doing the
Yes.
implicit derivatives. Okay. Now on the right, like imagine this were an x for a moment. Let's like this is called the independent variable. So you don't have to do this dy dx. Actually, it's dy dz. I should. So let me. I don't want you to mess that up when you put it in there. Let's call it dy dz, which is maybe a little clear. But this what is the derivative of z to the ninth? If it's just power rule, just pure power rule.
9z to the 8th.
Right. And you bring the constant down, natural log of 6 down. Okay. So this becomes 1 over y times dy dz equals this. Now we're solving for dy dz. So you undo, actually, let me just copy this down. You undo 1 over y by multiplying both sides by y. So you multiply everything by y, like that. And you can see that that y cancels with that y. But what is y? Well, y is the original function that you started with.
Mm-hmm.
So your answer is dy dz. And it is always the case that it looks like this. It's whatever you end up getting for your derivative times the original function, like this. So this is your final answer. I totally understand if this doesn't make any sense.
A little confusing.
Yeah, these are not the best examples to start with, but that is what we have in front of us. You be very careful how you enter that. I'm always willing to look at what you've entered, or if you want to send another picture snippet just to confirm that you've entered it correctly.
Okay. Should I add like multiplication signs or?
Yeah, I mean, you could put like the 9z to the 8th in parentheses. That would be good. Times 6 to the power of z to the 9th.
That's how I entered it. If that's right.
Natural log 6. I would not use the x. I would use a dot instead of the times there, where you got it between the.
Okay.
Let me snip this in so you can. So I would change that to with the dot, or just
Okay.
remove it altogether.
Okay, I changed it to the dot. Yeah.
Okay, good. All right, so let's see if we can get one more of these implicit ones done before we close out here. Not implicit, logarithmic differentiation with implicit differentiation. Okay, so again, you take the natural log both sides. So it's natural log of y equals natural log of t to the square root of 13t, like that. And then you always move the exponent thing out in front, like that. So you bring this out in front. This time, unfortunately, it's not a number. It's not like natural log of a number. So on the right, it's actually product rule when you do it. Derivative on the left, it is 1 over y times dy dx. And so product rule first times the derivative of the second plus the second times the derivative of the first. Now I'm just doing this because we're running out of time here. I'm just doing it for you, but keep in mind, there's a lot that goes into just being able to do something like this. So it's 1 over y times dy dx, square root of 13 t over t plus 13 natural log t over 2 square root 13t, like that. And then you have to, you're solving for dy dx. This is again where you multiply both sides by y. On the right, though, it's now in parentheses because you're multiplying everything by y. And in these logarithmic differentiation problems, you always, always, always get that original y as part of your answer. So take extra care entering this one. You know, the most common mistakes are just entering them into the thing. And this is times t to the square root of 13t because that's y there.
Okay.
All right, let me know when you get all that down.
Yeah, I answered it. I was just sending it.
Excellent.
I
Okay.
answered, like,
Yeah, looks good. Looks good. Okay, so we're gonna go ahead and stop here for today. Just curious, did you just hear anything I was listening to